I'm Mwangi Wanjoi, a EXPO final year student.
I'm Dominic Mativo, fifth year electronics and computer engineering.
I'm Tamaro Paul, a fifth year EXPO student.
So our project is a digital power distribution system. Now, we all have experienced a time whereby maybe your neighbor has got power and you have not power in your house. And maybe another situation is whereby in a certain building, in a big building, one side of the building has got power, another side has got no power. So this is called a single phase failure. It occurs whereby, maybe I'll give an example. In Juja supply of electricity, so by the whole of Juja is supplied by a three-phase supply, but each and every part of Juja is supplied by a single phase. So what happens is that this single phase supply, when a single phase failure occurs, you have no power in your power, but other people who are supplied by another phase are supplied by power because their phases are healthy. So our system tends to address this, whereby if one section if one phase has got no power, then you are switched to another healthy phase. So you continue enjoying the services whereby, that is if the capacity is there. Then in another instance whereby in a big building, for example, maybe you give this Hall 7 building, one part of the building has got no power and other phases has got power. So when power goes off in your phase, you can be switched to another healthy phase. So those are one of the major things our system is trying to address. Those are some other things it's trying to address. Maybe TK, you can take us through some other.
So when my colleague talked of single phase failures, you'd wonder what are the causes. A single phase failure is a symptom of that is sourced from this could be interruption of that phase, that line, which could be due to natural causes. A tree may fall on an electric pole and that line is out. And then there are the electrical causes which is overloading of a certain line. Those lines normally have fuses, rated fuses. So if we load it past the rated capacity, it will trip and those guys won't have power. So we are saying we are not only treating the symptom but the cause. Our system in a normal operation, when there are no those single phase failures, it's able to, because it's able to monitor the loading in all those phases, it's able to switch part of the load from those phases that are highly loaded to the less loaded phases, so that we avoid those single phase failures. And then with our system, if you live next to maybe a barrack, or there are these installations that are given dedicated lines, whereby those guys they'll never be out of power unless and otherwise. So such instances are such that they're supplied by a dedicated line. It's a physical dedicated line. But we are saying with our system, we are introducing virtual dedicated lines. They don't have to construct that line. So it's virtual through a program. We are saying our system is able to prioritize consumers. We have high priority, second, third, and all that. So we are saying the last guys that can be chucked out of power, it's like they are on a dedicated line, but it's virtual. So we are avoiding all that cost of having to construct that physical line. And then the other aspect, during when the power production is not enough, it's not matching to consumption, the remedy that Kenya Power has just to put off some load. So you get like some region, normally I think you have seen adverts in the papers, this region won't have power from this time to this time. So what they do with the current system, we have a feeder. For example, for Juja, we have a Juja feeder. It's like a switch that controls the whole of Juja. So if they want to lay off load specifically in Juja, they will put off the whole of that feeder. That means all guys supplied from that line, be it hospitals, schools, domestic supplies, they will be out. But we are saying with our system, the power rationing, we are bringing it down to the consumer level. We are saying the power rationing now is going to be specifically for a specific customer, not the whole line. So you're saying it to reach a case where we can leave installations such as schools, hospitals, because those are they are public installations and they serve more guys. So you're saying the system will be able to check out specific guys, not the whole area, so that prioritized installation can still have power when there is need to lay off some loads. So we're having a system. Majorly, the technology behind it is a changeover. I think like here in school we have a generator. So you normally realize when power is out, KPLC, the generator will peak and the load is transferred to the generator. It's the same technology we are using, but our technology is automatic and we have modified it such that when these instances we are describing occur, we are using an Arduino microcontroller. The program there is able to detect these instances have happened, and then it's able to switch. Because in that changeover we have contactors. These are electronic switches. Once they have the high or low, they will be able to switch appropriately. Yeah. So and then there are other parts of the project that my colleague will.
Our project incorporates a remote control and monitoring module that enables power distribution companies, like for example Kenya Power, to be able to isolate a certain customer and cut them off from the power distributions, and also they can be able to bring them again into the power by connecting them again. And other than that, they can also be able to change them over to any other line or any of those vehicles. And our projects also, we are collecting data from each and every distribution, so that in the long time you have a lot of data that you can be able to analyze and detect certain customer trends and also their power usage trends. And with this kind of data, you can easily know how to plan and around the certain circumstances, when things like during power rains, for example, you notice there are a lot of power shortages. So the power distribution companies can be able to plan around this using our data that we collected from the system. We will also be looking into capping power. We have illegal connections, because we have data at each and every point close to the customer, other than from the main control center. So with this, power distribution company can be able to isolate where exactly power is being stored. We can be able to isolate where there are certain discrepancies in power usages.
You're saying the whole thing, major partner in this could be KPLC. We are saying because they are the sole power utility provider. But still, the way my friend was explaining, for large buildings, they normally have a three-phase connection. So you are saying still, on that level, we can do it. If we are able to get our company running, we can be able to do such installations. And then probably, and other parts, like, there are those guys who would say, if Kenya Power doesn't adopt this, for me, I would like that during such single phase failures, I have an alternative source of power. So we can install those guys. But we would wish that Kenya Power can take this up. Because maybe to add on what he said about illegal power connections, Kenya Power is losing like 2.3 billion per year in terms of illegal power connections. And we are saying we can actually eliminate these. It can go. Those illegal power connections won't be there anymore. And then still, the other part I was talking of, load balancing, Kenya Power is losing like about 18% of their revenues to what we call distribution losses. And those losses occur when the loading in the three phases is not balanced. Our system is able to address that.